Today we're looking at odd and even functions. Now, it's really, really important. Functions are even if they are symmetrical about the y-axis. So we're going to look at them in terms of what the graphs look like. We're going to look at them in terms of properties of function of x and function of negative x as well. So the first thing is, if you see this concave down parabola, can you see there's my y-axis? Can you see that this parabola is symmetrical about the y-axis? So if the y-axis, if I fold the graph over, one half would sit on top of the other. So always for even functions, they're symmetrical about the y-axis. So they have a line symmetry or reflection about the y-axis. But there is another rule. Now the other property is that also for even functions, the function of x equals the function of negative x for all values of x. Okay? So you know how parabolas have x squared. It's easy to see why this would work. But sometimes not all parabolas will work. So show that function of x equals x squared minus 3 is an even function. So for even functions, function of x equals function of negative x. Now I know what function of x is. So I just work out what function of negative x is. So that's just telling me every time I see an x, replace it with a negative x. So that's negative x squared minus 3, which is just x squared minus 3. Now, doesn't that equal function of x? Isn't that what the function of x is? So therefore, it's an even function as function of x equals function of negative x. So to prove that something's an even function, you need to show, that's the rule, that the function of x is equal to the function of negative x. Okay, let's look at the next one. So show that this next curve, x to the power of 4 minus 2x squared plus 5 is an even function. So question 2, show that x to the power of 4 minus 2x squared plus 5 is an even function. So that's what function of x is, function of negative x, replacing each x with a negative x. So we've got negative x to the power of 4 minus 2 times negative x squared plus 5. Now negative x to the power of 4 is x to the power of 4 minus 2. Negative x squared is just x squared plus 5. So that is identical to function of x. So therefore, again, this is an even function as function of x equals function of negative x. Now, so that's even functions. Need to know two things, symmetrical about the y-axis and function of x equals function of negative x. Now, odd functions. Odd functions are not symmetrical about the y-axis. However, they have point symmetry. Now, you learnt about point symmetry, which is like a rotational symmetry of 180 degrees. Okay, so they have point symmetry about the origin. So, for example, if this is the origin, if I happen to get my ruler out and measure this point over here, if I continue with my ruler, this point here is the same distance away on the 180 degrees away, 180 degrees in a straight line. For example, this point up here, if I measured that distance to the ruler and kept the ruler going down here, that's, if this was, say, 4 centimeters up there, this point down here is 4 centimeters down there. So your typical curve would be an x cubed like this type. This is negative x cubed curve. The x cubed curve goes like that. These have point symmetry. So it has point symmetry about the origin. In other words, if you rotate this bit here 180 degrees, so that's 90, 180 degrees, it will then sit on about the origin, rotated 180 degrees about the origin. It'll give you back the original graph. So if I rotate this 180, it ends up there. If I rotate this 180, it ends up down there. Okay? All right, now also, just be careful here. For odd functions, the function of negative x equals negative function of x. So, show that this function of x equals x cubed minus 2x is an odd function. So let's have a look at function of negative x. Okay? So isn't that negative x all cubed minus 2 times negative x, which is what? What do you get? Negative x cubed plus or minus 2x. No. And plus 2x. Now, isn't that, I'm going to pull a negative out, that is negative bracket x cubed plus or minus 2x. if I pull the negative out. Minus 2x. Now, isn't that the negative, and that in the brackets is the function of x? Because function of x is x cubed minus 2x. So therefore, that's negative function of x. So therefore, this is an odd function, as the function of negative x equals the negative function of x. Can we see that? Okay, let's look at the next one. Have you noticed that, we'll have a look in a minute. So question 4, show that function of x equals 5x minus x to the power of 5 is also an odd function. So function of negative x is 5 times negative x minus negative x to the power of 5, which is negative 5x minus negative x to the 5, which is plus x to the power of 5, which is, pulling the negative out, negative bracket 5x minus x to the power of 5, which is negative function of x. Because what's in the bracket here on that second last line is the function of x. So therefore, again, this is an odd function, as the function of negative x equals negative function of x. So the function of negative x equals negative function of x. So you always will be checking to see if it's even first, because you always do function of negative x first, pretty much. Because you need to do function of negative x for both odd or even functions. See? For an even function, function of x equals function of negative x. But for an odd function, function of negative x equals negative function of x. So you're always working out the function of negative x. And if that equals the original function, then it's even. And if it doesn't, if it equals negative function of x, it's odd. But every function does not have to be odd or even. It can be neither. Okay, so let's look at question 5. And it says, show that function of x which is equal to x cubed plus x plus 1 is neither odd nor even. So first we do function of negative x. Now that is negative x all cubed plus negative x plus 1, which is negative x cubed minus x plus 1. Now that doesn't equal. Can you see that that does not equal the function of x? So it's not even, right? Now I'm going to pull out the negative. Or I'm just going to actually write down what negative function of x is instead of pulling this. I can pull the negative out here if I want, or I can just work out what negative function of x is. Wouldn't I just put a negative in front of all that? Negative function of x, isn't it negative x cubed plus x plus 1, which is negative x cubed minus x minus 1? Now, that does not equal the original function. So, the function of x does not equal the function of negative x, and the function of negative x does not equal negative function of x. Are we okay? So therefore it's neither even nor odd. So it's neither even nor odd. So we can see that this is not equal to function of x, and we can see that the function of negative x does not equal negative function of x. Okay? Proving it algebraically, that something's an even function or something's an odd function, but you might sometimes be asked to complete the graph if the function is an even function or if it's an odd function. So for example, if this is an even function, okay, let's say here's my y-axis. Don't worry, you don't know, I don't even know what this function is. And this is the x-axis, and here's my function. We know that even functions have symmetry about the y-axis. So if I was to complete the graph, it just has to be a reflection in the y-axis, so the rest of the graph would look like this. You get that? So complete the graph. So I've got that left-hand side of the graph. If I want to complete it so that it's an even function, I would do that. But you would do it in a solid line, but I just thought I'll do it there in a dotted line. Now, I'm going to do the same function, and if it's odd, I'm going to complete the graph if this function is odd. Now remember, that one's got point symmetry. So instead of, often it'll be in opposite quadrants. If this is in quadrant, you know, we've got quadrants 1, 2, 3, 4. If this is in quadrant 3, the point symmetry one will be over here. Because if I put a ruler through here, so this point here will be over there. Do you see how I'm going? And then this point there will be down here. Through the origin. It's got symmetry about the origin. Okay? That would be and I know I've drawn it a bit wider. I shouldn't draw it a bit wider. And if this, for example, was at the point -2, this would be at the point 2, for example. Do you get it? And over here, if this was the point -2, that would be the point 2. So even point symmetry about the origin, 2 to the left. Here, this is 2 to the right. You know, so many units down, so many units there. Up there, that distance. Down there, that distance. Like you've got a ruler going through the origin. Okay? Graphs of these functions if they are even or odd. Even, if it's an even function, and then if it's an odd function. Okay, even, symmetrical about the y-axis. So back up, down, and up. Yeah? And this other one, if it's odd, down here, whatever, up there, up here, and down. We get that? Okay, so whatever this is, same distance there, from there to there, from there to there, that should be the same distance, and then from there down to there. Okay? Also, you can look at them sort of in opposite quadrants as well, quadrant 1 and 3, quadrant 2 and 4. Okay, these ones, odd and even, so where would I come back here? Reflection in the y-axis here for the even function. So we'd come back up. So if it was even, we'd come back up, come across there, and then off to the left, up and off to the left, if it was an even function. So that's meant to be the same length. All good? I know I've got a discontinuity there, but it is a function because it's this is not a relation. It's a function because this is circled in and this is open circle there. So there are not two y values for 3. Okay? And if this was an odd function, I'd have to come down here. Yeah? Do we know what to do? And we would go down here, and then across, and then down here and there. All good? So, line symmetry about the y-axis and point symmetry about the origin.